This is a lesson on chapter 1.5, absorption, reflection, and refraction of the Year 9 and 10 Good Science textbook. Now, with this chapter, I thought I'd break it up into two lessons because it can be quite overwhelming. So I'll only be focusing on absorption and reflection in this lesson. So the title for today's lesson is chapter 1.5, absorption and reflection. Let's begin with light. So before talking about what light can do, it's important to first understand what light is. This should hopefully be a recap from the previous lesson on the electromagnetic spectrum. So let's define light, just to recap. Light. So light is an electromagnetic wave. And if you recall, electromagnetic is two words. It's two words in one. It's got electric, electro, and magnetic. It's an electromagnetic wave made of alternating or oscillating electric and magnetic fields. Remember, oscillate means to vibrate. You don't need to know what it looks like for the Year 9 syllabus, but I'll show you what it looks like anyway, just for you to have a good idea as to what it looks like. This is the picture that I want you to have for light. So light isn't just this yellowish haze that you see from displays or from the sun. It looks like this. So fields, if you remember back from juniors, from the Year 7 and 8 science, fields are things which cause objects to experience a force. So the most common is that of a magnetic field. If you look at the whiteboard, you'll see that there's hopefully an eraser on the whiteboard. It's stuck there because there's a magnetic field keeping it stuck on the board. Okay, you've got two opposite poles, a north and a south, attracting. So a magnetic field can be sketched like this. So I'll put arrows here. So I've drawn a transverse wave, and the arrows show that it's oscillating up and down. Because transverse waves, that's what they do. They oscillate up and down. Let's suppose the wave is moving to the right. Let's call this the magnetic field. That's the magnetic field. It's going up and down. But light also has an electric field component. It looks like this. It's going back and forth. So you've got these two fields oscillating at right angles relative to one another. Okay, back and forth. I'm putting arrows going back and forth in and out of the page, if you can imagine. And that's the electric field. Now, as you know, hopefully, electric fields form due to charges. If you have a proton, you've got an electric field coming out of the proton, or any positive charge for that matter. If you have an electron, a negative charge, they basically eat electric fields. They absorb electric fields. So electric fields, they come from charged particles. And that is what light is. It's a wave, it's an electromagnetic wave made of oscillating electric and magnetic fields. Okay, and it moves at the speed of light. It moves at 300,000 Ks per second. So that's what light is. And it's an electromagnetic wave made of oscillating electric and magnetic fields. And I'll stress once again, you don't need to know how to draw this. It's just important to understand. And of course, there's different types of light. That's what the electromagnetic spectrum is. It's a spectrum. It's a chart showing all the different forms of light. Okay, so light is an umbrella term. There's different forms of light: X-rays, ultraviolet, radio waves, gamma rays. They're all different forms of light. They're all the same thing, except they differ in their energy, frequency, and wavelength. Okay, so X-rays, for example, are higher energy than visible light. Okay, and it makes sense to use X-rays to scan bones in your body because they're high energy. They can penetrate your body tissue. Let's now look at the properties of light. Light can do things. It's not just this boring, static, stationary thing. It can do all sorts of things. So light can be transmitted, reflected, or absorbed when it strikes a material or a medium. So 3 things that light can possibly do. And I'll talk about these in just a sec. I'll highlight these, very important. And you're all familiar with these. These aren't new words, new terms, or new properties of light. You've all experienced these in your everyday life, hopefully. Let's look at these properties in some detail. Okay, let's look at, so using these properties, let's look at the types of materials that exist. There's three main types of materials. The first are what are called transparent materials. I'm sure you know what the word transparent means. Transparent means see-through. If you focus your attention over the smartboard, what I did this morning before class was stick a piece of plastic up on the wall. So if you take a look up there, there's a piece of plastic. That's an example of a transparent material. It's see-through. So I want you to have a picture of what that means. Transparent, it's see-through. And the reason why it's see-through is because all light passes through it, which equals see-through. So you get a clear image. Okay, let's suppose I've got a picture here of a person. You have this clear picture of a person. If you have a massive plastic sheet, see-through sheet, and you put it in front of a person, you can see hopefully the person standing in front of you clearly. So transparent materials, see-through. Then there's translucent materials, probably a less familiar term. Translucent. These are partially see-through, half see-through, half not see-through. And you get this sort of fuzzy image. So an example of a translucent material is tissue paper. So I stuck a piece of tissue paper on top of the smartboard as well, next to the piece of plastic. So some light passes and some is reflected. Okay, so some goes through the tissue, some bounces back. If any of you have a tissue with you, you can pull it out of your pocket or out of your bag, and you can hold it in front of someone and you can probably see the person slightly. That's an example of a translucent material. Only some of the light is absorbed and some is reflected. And you get like a fuzzy image. So suppose here's the tissue. The person that you've put it in front of looks a bit fuzzy. So that's a translucent material. It's fuzzy. And the very last type of material is called an opaque material. I'm sure you've heard of this word. Opaque means it doesn't allow any light to enter it. Okay, you can't see anything, in other words. Opaque materials are far more common. Things like bricks, if you look at the brick wall, tables, chairs, human beings for that matter. So these aren't see-through, they're not translucent, so no light enters. Okay, it's either absorbed or reflected. So you get no image seen. Opaque means no image. So here's the tissue, you can't see the person. Let's suppose the tissue was designed so that it's opaque. You can't see the person at all. So from transparent to opaque, less and less light is making its way through the material. Hopefully that makes sense. So just to recap, light is an electromagnetic wave. It's made of oscillating electric and magnetic fields. It can be transmitted, reflected, or absorbed. And there's three types of materials: transparent, translucent, and opaque. Transparent allow light to flow through it completely. So just a note now about absorption and reflection. I'll start with absorption because it's more straightforward. Let's look at absorption. It's a very straightforward concept. If you hear the word absorb, I'm sure the first thing that comes to mind is clothes absorbing water or something like that. So absorption is basically due to atoms in a material absorbing the light waves. So the atoms are like a sponge. They absorb the light. And the reason why objects that are like blue, if you look at the sticky note that I've stuck up on the wall on top of the smartboard, that blue sticky note is blue because it absorbs all the colors of the rainbow except for blue. It reflects blue, and that's why it makes it blue. So e.g. blue sticky note absorbs all colors except blue. Okay, it reflects the blue. So I'll keep it at that. That's absorption. That's why grass is green. It absorbs all colors of the rainbow except for green. It reflects it, and so on and so forth. That's absorption. So it's to do with the atoms in a material. And the last bit of this lesson is reflection. Now this involves a bit of maths, a bit of drawing. So I'd highly recommend you have like a ruler and pencil. It's good practice. So let's continue on into reflection now. Reflection is something we're all familiar with. First thing you do when you get up in the morning, I'm sure, is look at a mirror, groom yourself, looking at yourself in a window's reflection, walking past the shops, reflection in a lake from the water. Reflection is simply the bouncing off. So it's when light bounces off a surface. Could be anything. Typically a smooth surface, e.g. smooth. And it changes direction. So that's why you can see your image in the mirror, because the light hits the mirror and it bounces off. It changes direction. So that's reflection there. It's a simple definition. Now in physics, we have what are called ray diagrams. To understand reflection. In Year 11, it's the same thing. Year 11 physics, we do this stuff. Doesn't get more complicated than this. There are things called ray diagrams. Now, light can be pictured as rays, light rays. I'm sure you've heard of light rays. They're basically imaginary lines that indicate the direction of light. Okay, that you can't see them obviously in everyday life, but you can picture it. You can draw it as follows. So suppose you have a mirror. So we draw a mirror like this, a flat horizontal line. That's a mirror there. It's a flat surface. If you you can draw this using pencil, that would be great. You have a light ray coming in, striking the mirror at some angle. This is called the incident ray. Incident ray is the ray that's coming in, right? Just think of the word in, incident ray. When it hits the mirror, it bounces off. And that ray that's reflected is called the reflected ray. No surprises here, because it's reflected off the mirror. So the incident ray, that's the incoming ray. Okay, the lines, these are rays. Now, we typically draw a dotted line that's at 90 degrees perpendicular to the mirror. This is called the normal. In physics, normal means anything that's at 90 degrees. It's an imaginary line at 90 degrees to the mirror. And the angle between the incident ray and the normal, that's called the angle of incidence. And in physics, we give it the symbol theta. Sure, in maths, you know what theta is. Theta stands for angle. It's a Greek letter. Theta with a subscript I. Theta sub I. That is the angle of incidence. Okay, between the incident ray and the normal line. That's why it's called the angle of incidence. And no surprises, you have the angle of reflection. Theta sub R. R for reflection. That is the angle of reflection. So very simple diagram for any flat surface like a mirror. The incident ray coming in will bounce off the mirror, gets reflected off, and you have these angles formed between the rays and the normal. This is called a ray diagram. There's a law, it's called the law of reflection. It basically says that the incident ray, angle of incidence, theta sub I, is equal to the angle of reflection, theta sub R, quite simply. That's called the law of reflection. It states that theta sub I is equal to theta sub R. This is only for flat surfaces. It's a very simple relationship here, mathematical relationship. It's called the law of reflection. And that's it. That's what a ray diagram is, and that's the law of reflection. Only applies for smooth surfaces like mirrors, flat surfaces. We don't look into rough surfaces, even for year 11 physics. It's too complicated. Angles become warped, and the maths gets more complicated too. Now, that's an example there of light reflecting off a surface. Now, as you know, you can manipulate light. You can make it reflect using things called mirrors. Let's get into mirrors now. So this is continuing on. Mirrors. Okay, typically made of glass with a reflective surface like a film. And there's two main types of mirrors. You've got concave and convex. These are just names. But with concave mirrors, think of a cave. They cave in like this. There's a two-dimensional image here. Caves in. So that's how we draw a mirror, a concave mirror. And we draw light rays typically hitting the mirror like this. So we'll draw 4 parallel light rays. These mirrors, if you look at the shape, the concave mirror, they converge the light rays. They make the light rays meet at a common point like this. So this one here meets up here. These two middle ones, because they're striking the surface here where it's flat, they'll bounce back. They won't reflect at an angle. And this one here at the edge will reflect back at an angle, and they'll meet at a common point there. That point there is called the focus. It's called the focus. That's where the light rays are focused onto a point. We'll see how this works in the lab. And sometimes they'll typically as well continue on. Some of the light will continue on. So from this mirror here, this light ray here, it'll bounce like that. And from this one here, it'll continue on like that. That's a concave mirror is also known as a converging mirror. Converge means to meet at some point. Okay, think of traffic, converging traffic. Converging traffic means the traffic's meeting up at some point. There's like a bottleneck or something. So that's a concave converging mirror. It basically focuses the light onto a point called the focus. They meet up, and then some of the light rays might also come back out again. Okay, they continue on in the straight direction. Convex mirror is the opposite. So it doesn't cave in, it caves out like this. So we'll draw 4 light rays once again like this. And if that's a converging mirror, this one's going to be a diverging mirror. Think of diverging traffic. The word diverge means to spread out, right? So the outer 2 will reflect off at an angle like this. If I could squeeze it in. So in and then out like this. And the middle 2 will just simply bounce back because here the surface is flat. And this is known as a diverging mirror. And typically you will notice on the other side, these rays that are reflected tend to sort of meet here. That's the focus there. It's just a weird property of mirrors. You find that some of the light is on the other side of the mirror. So converging mirrors, they're useful in things like fine torches, laser pointers, and diverging mirrors are typically useful in, concave mirrors are even useful in satellite dishes because they're shaped like this, and a satellite dish will typically take in the radio waves. Okay, remember radio waves are a form of light, electromagnetic waves, and they'll focus them onto a point. Satellite dishes, convex, typically use the magnifying glasses, okay, because they want to make the image bigger. We'll quickly do some examples now of the law of reflection, see how that works. Okay, law of reflection, let's do some examples. So e.g., suppose you have a mirror here. You have a light ray coming in, light ray reflecting off. Here's the normal. Suppose the angle of incidence is 50 degrees. You need to work out the angle of reflection, x degrees. If you recall, the law of reflection states that the angle of incidence, theta sub I, is equal to the angle of reflection. So if the angle of incidence is 50 degrees and it's a flat surface, a mirror, therefore the angle of reflection will be 50 degrees too, and that's x. Quite simply. We'll do another example. Suppose you have another mirror. Incident ray, reflected ray, here's the normal. Suppose we know the angle of reflection to be 70 degrees. We need to work out the angle of incidence, y degrees. Well, once again, law of reflection states that the angle of incidence, theta sub I, is equal to the angle of reflection, theta sub R. If the angle of reflection in this case is 70 degrees, for this relationship to be satisfied, the angle of incidence must be 70 degrees, and that's y. And that concludes this lesson on absorption and reflection. So to recap quickly, light is an electromagnetic wave. It's made of electric and magnetic fields. It can do stuff like be transmitted. It can go through materials. It can be reflected off materials, or it can be absorbed. Materials come in 3 main types: transparent, translucent, and opaque. Transparent is see-through. Translucent is half see-through. Opaque is not see-through at all. Law of reflection states that light, when it bounces off a surface, the angle of incidence is equal to the angle of reflection. And mirrors, they come in 2 main types: concave, which converge, focus the light rays, and convex, which diverge, make the light rays spread out.